Okay, at 9 volts here, which is, oh, there we go. I've said the minimum requirement for the circuit is like 9 volts, and as you can see, 9 volts through the circuit sort of lights up. Good day, and welcome to the Alberti-Base. Today, we're doing a super exciting project for me. It's become sort of a rite of passage if you're doing electronics on YouTube to build your own Tesla coil. So that's what we'll be doing today. For those of you who were hoping on a video to show you how to build a Tesla coil at home, this is it. It's going to be very easy, and this one is also the safe version of a Tesla coil. The future ones are going to get a bit dangerous, but for today, our video is safe. So first, let me explain what we'll be doing. I'll draw some circuit diagrams, and then I'll explain how all the parts fit together. Now, if you haven't seen my video on how to shock yourself with an Arduino, you're about to be very lost, because everything I'm using here, I explained there in detail, and I don't like repeating myself. So if you haven't seen that, go check that out first and then come back here so you can understand what I'm saying. The most important part of a Tesla coil is the actual coil, so I'll draw that first. The primary coil is a coil that will be made of thick wire, and we'll be using around 4 windings or so. So we'll draw that 1, 2, 3, 4, our primary inductor. Our secondary coil will be much larger, as you can see up there. It has to have almost 1,000 windings, so our voltage upstep ratio can be high enough. So I'll draw that. Now usually, with an iron core or a ferrite core transformer, we'll be using some lines between those to denote that it's an actual magnetic coupling. But in here, the magnetic waves are coupled by air only, and that's also the reason why it can actually transfer wireless power. Now the primary coil, we need to switch on and off many times a second to create an oscillation, and that AC power we need to step through a transformer, as I explained in another video. And for that, we'll be using a transistor. First, let me draw a power supply. The battery is easy to draw, plus and a minus, and this could be anything from about 9 to 30 volt, let's say. It can be higher, it can be lower, depending on what your circuit can handle. Also, I'll be using a transistor to rapidly switch on and off the primary coil. I'll draw that here. Now, you remember the names of these pins from the previous videos? These are collector, emitter, and base. The emitter goes directly to the secondary coil or the primary coil, which connects to ground, or the negative pole of your battery, which is also connected to ground. The notation for ground is the same symbol, and that just means everything is connected to like a negative point or the ground in your main supply. I don't have to connect everything with a line at the bottom for you to understand what I mean. Now the bottom of the large secondary coil with 1,000 windings, we want to use to give feedback to the primary circuit. We'll do that by wiring it up to the base of our transistor, like that. Please, once again, excuse my drawing. Now, the battery's positive pole connects up to the collector of the transistor. To start the oscillation and to actually give a turn on and off motion, we also need to connect the positive pole of the battery to the base of our transistor. But we can't do that directly for reasons I'll explain in a minute. So we'll do that across a 10 kilo ohm resistor. So, as you can see, I've redrawn the circuit, and I hope this is a bit neater and easier to understand, although it's not much. Anyways, let me explain how it works. When we turn on the circuit, the current flows from the battery through here, through the 10k resistor, to the base of the transistor. When it's turned to the base of the transistor, a circuit opens over here, so current can flow through the primary coil over here. A current flowing in the primary coil induces a bunch of magnetic fields that induces a current flowing in the secondary coil. Current flowing in the secondary coil flows through this wire over here, also to the base of the transistor. Now what happens here is a current from the left and a current from the right crash into each other, basically, and that pushes the current from the left away, turning the base of the transistor off, so current can't flow through the primary coil anymore. Once current can't flow through the primary, well, the current through the secondary also can't flow, and so current can once again flow through the 10 kΩ resistor, turning on the base, turning on the primary, and also oscillating again through the secondary coil. This motion repeats like thousands of times per second to create the oscillating motion and AC wave we need to power our Tesla coil. Now the reason we're using the 10 kilo ohm resistor over here is because the current flowing from the battery straight to the base would be way too large for the current induced in the secondary coil over here to even marginally try to turn off. So we need to limit the current flowing to the base from the battery, as we don't really need any current to the base to turn on the transistor, so we can make the resistor actually quite a bit larger even. And that just makes it easier for the Tesla coil to stop the current flowing from the battery and turn the circuit on, off, on, off, on, off again, so that the current that's flowing through the primary coil over here looks something like this when you measure it. Now that we have a circuit on paper, we can go ahead and build it on a breadboard. Now, I've been getting some feedback from you guys and some questions asking, why do I build everything on a breadboard? Why don't I build stuff more compact and actually solder the components onto some wire board? And the answer is actually really simple. In terms of money, we have no money. But I also like building circuits on the Samvara board, and I have some of that. And this teeny tiny Tesla coil is only the beginning of what we'll be doing. I've already designed a more powerful musical Tesla coil that can create some much larger sparks, power things from much farther away, and, as the name suggests, play music. But if you guys want to see that one and see me build it and actually solder it into place, because I will be doing that one on a permanent board, if you guys want to see me do that, you're gonna have to help me. See, I've been thinking to make that video my 100 subscriber special on YouTube. And so if you're not subscribed already, why the hell are you watching this and you're not subscribed? It's subscribe now, go do it. And if you are subscribed and you have some techie geeky friends, share this video so they can also come and subscribe and we can get to that musical Tesla coil. So for the parts of the actual Tesla coil itself, I have like a very thick syringe, which I've covered with this thin, I hope the camera can even see that, with this thin copper wire. And to the bottom of the thin copper wire I've soldered a thicker lead, so we can actually connect that to a breadboard without worrying about damaging the thin lead or breaking the coil inside because it's quite fragile. I've also covered this with purple duct tape, white purple. No, I'm not gay, but it's the only color I had available. For the secondary coil, I've used some unisolated copper wire, which creates a nice and thick coil, and I've soldered some leads to the end of that, so we'd also be able to connect it to a breadboard. And these two parts assemble really easy. What you do is you take this one and you just insert it into this one. Easy. Now I'll bring closer my breadboard, and you can see it has these nice screwy plugs at the top. Each of them has like a hole in here which I can also plug jumper wires into. So I'll be using these plugs to connect the wires of the coil to my breadboard.
New Pantene doesn't just wash your hair, it fuels it with the first Pro V nutrient blend, making every strand stronger.
Actually, you know what? This is going to be very boring for you guys to watch. Just cue the build montage. Go! And there you have it. All done. As you can see, if I move this into the camera, I've 3D printed a nice base for it. You don't need to do that, you can just glue it to a piece of cardboard, like something like this. You can just glue it to some cardboard. The leads over here are going to my power supply, which I'll be running at an increasing voltage by just turning the knob. And everything else is as simple as we described it earlier on the circuit board. Now I can't really just go and turn that on yet, because if you remember what I said earlier, there are some flaws in the circuit. The main one is that the primary coil of this thing is an inductor, And an inductor is a short circuit to DC, meaning that when DC is running through it, there's no real voltage over it, and so a bunch of energy is being wasted. And the waste bucket of our circuit, as you can call it, is a transistor, which is why it has like a metal back. Let me show you actually. I can take one of these. You can see the back is made of steel, and the reason for this is so you can attach a nice heat sink to it. A nice heat sink. Damn my English. Anyways, so to do that, you'll need some thermal paste, which, as I'm saying this, I realize I don't have. Technical error. As I was saying, to attach a heat sink to a heat sink, I really hate that word. Anyways, to attach a heat sink to a transistor, you'll need some thermal paste, yeah, sure. But I've searched my home and what I came up with is Colgate's new brand of thermal paste, which is me repurposing my toothpaste to make thermal paste. If you've seen PC building videos, you know that you can do this. Totally, like, trust me, you can do this. So let's use the toothpaste and heat sink I have over here and attach that to the transistor so it doesn't overheat. Actually, this is way too much. Technical error. Anyways, lesson number 1 with thermal paste, whatever you think is enough is already way too much. So I've sort of cleaned up here, and as you can see, I've also bolted the transistor to the heatsink using a small screw and a nut. I'll insert this back into its place where hopefully it won't be overheating anytime soon. So now that that's installed in there, we can turn on the circuit. Right now the power supply is at 0 volts. I'll slowly turn it up, holding the bulb next to the coil so we can see what happens. At 5 volts now. Okay, at 9 volts here, which is, oh, there we go. I've said the minimum requirement for the circuit is like 9 volts, and as you can see, 9 volts through the circuit sort of lights up the coil, but not from very far away. If I look, I don't think the camera will pick it up, but there's like a very tiny purple spark going on the end of our Tesla coil over. Ow! Actually, that more tingled. Anyways, go up a bit. At 12 volt, you can see the light getting significantly brighter when I hold it around the coil. Let's go up. We can do up to 30 from this supply. At 15 volts over here, doing nice. Oh, there's a little purple tiny thingy that's appeared on the end of my Tesla coil. Let's turn this up. We can make it bigger. There we go. Look at that, it's moving around because it's literally ionizing oxygen particles. That's why it's moving like this. It's because the oxygen atoms around it's being ionized and split into two with positive and negative values and the electrons firing off it, and that's what giving this purple halo effect. When I bring the bulb next to even the tip of the coil, you can see it lighting up like crazy, and when next to the coil, it's really lighting up. I don't know if the camera is going to pick up the difference. But this is what Nikola Tesla intended with this coil. This is awesome, if you ask me. Here we go. Now we can wirelessly transfer power and turn on a bulb without any electricity, making what I believe to be the world's coolest magic trick. So there you have it. This was quite a trial and error process, but it works. It's the slogan of my channel. It freaking works. And I'm glad it does. Now, if you want to see me do this with a much more optimized circuit, transistors that don't get that hot, and some capacitors with high voltage, as well as play actual music through the coil, hit subscribe and get your friends to subscribe so we can get to 100 subscribers and get that musical Tesla coil video going. If you like this video, please hit like and leave a comment. As always, just say hi to me and tell me what I can do for you next, and if there's any questions you have, pop them there and I'll answer them as soon as possible. As always, thanks for watching. Alberti-Base out.